Problem number 14. Expand the binomial series of 4 plus x squared under root up to 6 terms by using method 6. I'm going to expand the binomial series of 4 plus x squared under root up to 6 terms. We will go up to 6 terms by using method 6. Since under root equals to 1 over 2, therefore I can write 4 plus x squared to the whole 1 over 2. So the power of this binomial expression is 1 over 2, which is in fractional form. It satisfies the condition. So from the binomial theorem that we have, a plus b to the whole n equals to this expression, we have to expand the binomial series up to 6 terms. 1, 2, 3, 4, 5, 6. 6 terms. Since it goes to infinity, we can't go up to infinity. We need to go up to 6 terms. I repeat it, the binomial expression for method 6 can be anyone. Can be NCR, can be first factorial, can be second factorial. It is up to you. The difference is that you have to add infinity. Like the series is not ended here. It goes to infinity. The given binomial series is 4 plus x squared under root. It can be written as 2 into 1 plus x squared over 4 to the whole 1 over 2. This under root, this yellow thing, can be written as 1 over 2. Now we have to take 4 under root common. Just take 4 under root common from here. So we're gonna have 4 under root into 1 plus x squared over 4. 4 under root equals to 2. Therefore I have 2 here. I repeat it. Since I need 1 for the first term. First term should be 1. Therefore I'm gonna take 4 under root common. When you take 4 under root common, you will have 4 under root into 1 plus x squared over 4. But since 4 under root equals to 2, therefore I put 2 here. And don't forget, for under root I put 1 over 2. So it satisfies all the 3 conditions. We can see here now that my first term a equals to 1, which should be 1. And my n is in fractional form, 1 over 2. It should be in negative form or in fractional form. It is in fractional form now. X squared over 4 must be less than 1 for the series to be converged. So apply the binomial theorem on this part and this part. Forget about 2 for a moment. What is my n? My n is 1 over 2. So plug in n equals to 1 over 2, 1 over 2, 1 over 2, all the way for all the yellow n's. What is my a? My a is 1, so plug in a equals to 1 all the way for all the red a's. What is my b? My b is x squared over 4. So plug in x squared over 4 for all the b variables. Remember, we have this bracket for all these expressions. There is a bracket. By plugging all the respective values in the above binomial theorem, I'm gonna have this expression on the right side for 2 into 1 plus x squared over 4 to the whole 1 over 2. Put 2 as it is, which is this 2, and apply the binomial theorem here. As I said, my n is 1 over 2. So plug in n equals to 1 over 2, 1 over 2 all the way for all the yellow n's in this binomial theorem. Look, actually a is 4, but then we took 4 common. But then we took 4 under root common because I need 1 for the a. So I'm gonna plug in a equals to 1, 1, 1 all the way for all the red a's. What is my b? My b is x squared over 4. So plug in x squared over 4 for all the b variables. You will get this expression. But please don't forget, it goes to infinity. It is not ended here. It goes to infinity. We are just taking 6 terms. 1, 2, 3, 4, 5, 6. We expand this binomial series only up to the first 6 terms. The further simplification, at the end we're gonna have this kind of expression. Just to simplification here, 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, 4 factorial is 4 times 3 times 2 times 1, 5 factorial is 5 times 4 times 3 times 2 times 1. Look, 1 to the 1 over 2 is 1, therefore I have 1 here, and x squared over 4 to the whole 0 is 1. Here 1 to the 1 over 2 minus 1 is ultimately equals to 1. Therefore I put 1 here. X squared over 4 to the whole 1 is x squared over 4. Similarly, 1 over 2 minus 1 into 1 over 2 is negative 1 over 4. 1 to the 1 over 2 minus 2 is 1. It equals to 1. X squared over 4 to the whole squared is x to the 4 over 16. 1 over 2 into 1 over 2 minus 1 into 1 over 2 minus 2 equals to 3 over 2. But then don't forget we have 3 times 2 times 1, which is 6 in the denominator. 1 to the 1 over 2 minus 3 is ultimately equals to 1. Whatever power you take for the 1, whether it is in negative or in fractional form, or in millions or in billions, or even 0, it ultimately equals to 1. Therefore, this whole thing equals to 1, and this whole thing equals to 1. Now 1 over 2 into 1 over 2 minus 1 into 1 over 2 minus 2 into 1 over 2 minus 3 equals to negative 15 over 16. 4 times 3 times 2 times 1 is 24. 1 to the 1 over 2 minus 4 ultimately equals to 1. X to the 2 over 4 to the whole 4 equals to x to the 8 over 256 plus 1 over 2 into 1 over 2 minus 1 into 1 over 2 minus 2 into 1 over 2 minus 3 into 1 over 2 minus 4 equals to 105 over 32. 5 times 4 times 3 times 2 times 1 is 120. 1 to the 1 over 2 minus 5 is 1. X to the 2 over 4 to the whole 5 equals to x to the 10 over 1024 plus infinity, which can be further simplified to have 2 into 1 plus x squared over 8 minus 1 over 8 into x to the 4 over 16 plus 3 over 48 times x to the 6 over 64 minus 15 over 384 times x to the 8 over 256 plus 105 over 3840 times x to the 10 over 1024 plus infinity. 1 times 1 is 1. 4 times 2 is 8. This 2 goes up, so 4 times 2 is 8. Therefore, I have negative 1 over 8. Negative 1 over 8. Similarly, the 6 goes up and it will have the product with the denominator, which is 8 here. 8 times 6 will be 48. So I will have 3 over 48. Similarly, this 24 goes up and has a product with the 16 to have 384. 120 goes up and has a product with 32 to have 3840. By taking the product of 2 with all the terms, I will have this expression. Just take the product, because remember we have the product of 2 with all these terms, So 2 times 1 is 2, and then 2 times x squared over 8 is x squared over 4. This 2 cancels with the 8, so I will have 4. Similarly, the product of 2 times 1 over 8 times x to the 4 over 16 is negative x to the 4 over 64. 2 times 3 over 48 times x to the 4 over 64 is x to the 6 over 512. 2 times negative 15 over 384 times x to the 8 over 256 is negative 5 times x to the 8 over 1638.4. 2 times 105 over 3840 times x to the 10 over 1024 is 7 times x to the 10 over 131072 plus infinity. Just take the product of 2 with all the terms individually. You'll get this expression. So I can write 4 plus x squared under root equals to 2 into 1 plus x squared over 4 to the whole 1 over 2 equals to this right side. We expanded this binomial series up to 6 terms. 1, 2, 3, 4, 5, 6. And one thing to be noted, for the infinite series, by using method 6, because of this n, which is in fractional form or in negative form, you may have these alternate signs, positive, negative, positive, negative. So I can write that the series is true and converges at x squared over 4 modulus less than 1. Look, we know that this is infinite binomial series. So to make this series able to be converged, we need finite sum. We need something finite for the convergence. We are pretty much familiar with the convergence, the region of convergence. The region of convergence is the region where the series converges. So it only converges if modulus b, which is x squared over 4, if this is less than 1, if it equals to 1 or greater than 1, then this series is not true and does not converge. It is only true and converges at x squared over 4 modulus less than 1. Why I wrote this series is true only when b modulus is less than 1. This is the prerequisite. If you remember, there are three prerequisites. One, that the first term must equal to 1, the second term must be less than 1, and the n value must be negative or in fractional form. If there is a lack of only one condition among these three conditions, your series is not true. Your series is only true when it satisfies all the three conditions. But for the convergence, it is compulsory that b modulus must be less than 1, which means that x squared is less than 4. Look what I did. I multiplied both sides by 4, so I got x squared modulus is less than 4. From x squared over 4 modulus is less than 1, we got that x squared modulus must be less than 4. Less than 4. When you multiply both sides by 4, 4 cancels with the 4 on the left, and on the right you're gonna have 1 times 4, which is 4. Therefore I have x squared modulus less than 4, which means that this x squared must be less than 4. Only then this b modulus will be less than 1. If x squared equals to 4 or greater than 4, then b modulus will be greater than 1 or equal to 1. Suppose if I plug in x squared equals to 4, I will have 4 over 4. 4 cancels with the 4, so I will have 1. I need something lesser than 1, not equal to 1 or not greater than 1, lesser than 1. Similarly, when I plug in this x squared equals to greater than 4. If x squared is something greater than 4, then I will have the value which is greater than 1. I need something lesser than 1, not greater than 1. Therefore, this x squared must be less than 4. Must be less than 4, like 2, 3, 3.5, 3.8. Only then this b term will be less than 1.